Have you ever wondered why a hot air balloon lifts off the ground or why a soda can hisses when opened? Today we'll discover how pressure, volume, and temperature choreograph every gas particle's dance. We'll start with the particle picture. Meet three classic laws one by one, and finish by combining them into one powerful tool. Picture gas molecules as countless tiny bouncy balls ricocheting off walls and each other. Each collision exerts a push we call pressure. The space those balls occupy is volume, and their average kinetic energy sets the temperature we measure. First up, Boyle's law keeps temperature constant and reveals an inverse seesaw. Squeeze the volume and pressure rises. Expand the container and pressure falls. Algebraically, initial pressure times initial volume equals final pressure times final volume, or P1V1 equals P2V2. Try this. Trap gas in a cylinder and have its volume while holding temperature steady. The pressure doubles, so you feel twice the resistance on the plunger. Quick check. If a diver's tank valve opens and pressure drops to 1/3, volume balloons by what factor? You should get 3 times the original space. Next, Charles's law keeps pressure constant and links temperature and volume in direct proportionality. But only when you count temperature in Kelvin. Heat a balloon from 300 Kelvin to 600 Kelvin and its volume doubles. Explaining why hot air balloons soar when the burner roars. Cool the same balloon to 150 Kelvin and it shrinks to half. That is why winter air makes once snug tires look slightly deflated. Gay-Lussac's law locks volume and lets temperature and pressure move together. Raise one. Raise the other by the same ratio. This is why a sealed aerosol can warn against sunlight. Warming from 300 Kelvin to 450 Kelvin hikes pressure by 50%, risking rupture. Reverse the idea and a glass jar in the freezer experiences a pressure drop that can suck in the lid or even implode thin walls. Finally, the combined gas law frees all three variables, stitching Boyle, Charles, and Gay-Lussac into one tidy fraction. P1V1 over T1 equals P2V2 over T2. Imagine taking a scuba cylinder from a 35 degrees Celsius boat deck into 15 degrees Celsius water. While external pressure climbs, the law predicts the new internal state in one step. Plug in the starting pressure, volume, and Kelvin temperature, then the final temperature and whichever of pressure or volume you know, and solve for the unknown. Pause and predict. A weather balloon starts at sea level with 1 atmosphere, 50 liters, and 290 Kelvin. At altitude, pressure falls to 0.3 atmospheres and temperature to 220 Kelvin. What volume does it reach? Work it through and you should land near 370 liters. We have seen that holding any two of pressure, volume, or temperature constant reveals a simple proportion, while the combined gas law handles the messy real world where everything changes. Keep observing. Every breath, every bubble, every breeze obeys these rules. Your next step is to measure them yourself and see the invisible choreography in action. Generate your own educational videos for free at eduvids.vercel.app.